Today we start our unit on exponential functions, okay? And I want to know if you know what makes something an exponential function. Like, for instance, y equals x squared. That has an exponent. Is it an exponential function? What did I tell you this was before? We talked about that being a quadratic, right? Because it's raised to the second power. So can it be a quadratic and an exponential at the same time? No. What makes something an exponential function? Is this an exponential function? No. Even though it has an exponent? Even though it has an exponent, it's not an exponential function. What makes something an exponential function? Where's the variable here? In the base, right? In the base. The squared is what makes it a quadratic. What do you think about an exponential function? Where's the variable? In the exponent. So, like y equals, I don't know, 2 to the x power? Is that an exponential function? Do you see the difference between these two equations? One's a quadratic and one's an exponential. It depends on where the variable is. Does that make sense? Okay. So let's slowly make our way through this page. There's going to be some things you're going to want to observe. And while I usually encourage you to observe things like that, today I want you to keep them in your head until I ask for them. Fair enough? Because I really need everyone to have a chance to observe these things. Okay? So look at problem number 1. Well, before we do that, let's read the directions. The basic form of exponential functions is y equals a times b to the x, where a and b are constants. So they're numbers, they're not variables. Okay? What effects do a and b have on the tables representing these functions below? Find out by using a calculator to complete each table. You need your calculators. So start here. Y equals 3 times 2 to the x power. For those of you that got your calculator like you're supposed to every day, good job. Go ahead and put that into, start a new graph, put that into y equals, and let's go look at the table. First of all, if we refer back to what they told us in the directions, y equals a times b to the x power, it would look like this, right? A times b to the x power. Can you tell me what a is in this problem? 3. Can you tell me what b is in this problem? 2. Good. Okay. So when x is 0 in this problem, what is y? 3 times 2 to the 0 power. Well, 2 to the 0 power is 1, because anything to the 0 power is 1. What's 1 times 3? 3. What if x is 1? 6. If x is 2? 12. If x is 3? 24. And if x is 4? 48. And how did we figure that out? Yeah, we used our table in our calculator, okay? We could take the time to figure all this out, but we already know how to do the math. We're using the calculator to speed up what we can actually get to. Fair enough? Okay? What's this word mean right here? A fraction. That's exactly right, okay? So what we're going to do is we're going to take a table value, like 48, and we're going to divide it by the one before it. What's 48 divided by 24? 2. What is 24 divided by 12? 2. What's 12 divided by 6? 2. What's 6 divided by 3? 2. So when we get to the end of each one of these 6 problems, there's going to be some things that you notice, but we're not going to say them out loud. This is what we're going to do. All together, we're going to go, All together, ready? Now look at problem number 2. If we have a times b to the x power, what is a? 2. And what is b? 3. Put that into the y equals of your table, or of your graph function, excuse me, and then look at your table. When x is 0, what is y? 2. When x is 1, what is y? 6. When x is 2, what is y? 18. When x is 3, what is y? 54. When x is 4, what is y? 162. How do we find the common ratio? What's 162 divided by 54? 3. What is 54 divided by 18? What is 18 divided by 6? 3. What is 6 divided by 2? 2. Oh, 3. And now? Are you starting to notice things? Don't tell me what they are. I just want to know if you're noticing things. Look at problem number 3. Y equals 6 to the x power. Wait, I thought it was supposed to be a times b to the x power. What's a? How do you know that 6 is b? How do you know which one is a and which one is b? Yeah, b is the one with the exponent. Okay? This one has an exponent, so it's b. In this case, is there an a? Yes, it's just not written. Okay, that's correct. A is 1. Okay? So get that in your table and let's look at the values. When x is 0, excuse me. When x is 1, 6. Oh, sorry. I wrote the wrong thing. I apologize. You said 1 and I wrote 6. I don't know why. 1 is 6. What's 2? 36. What's 3? 216. And what's 4? 1296. Also known as 1296. Or some people say 1296. Either one's fine. Okay? What about the common ratio? What's 1296 divided by 216? 6. What's 216 divided by 36? 36 divided by 6? 6 divided by 1? 6. Do you always have to start at the bottom? I've started at the bottom every time. Can I start right in the middle of the table and say 36 divided by 6? And get 6, and then 6 divided by 1 and get 6, and then go down here? Yeah, that's okay. What about number 4? How do I tell the difference between my A and my B? Perfect. B has an exponent. So what is B in this problem? Oh, sorry. Go back to here. Go back to the number 3. We observe things, and then what do we say? Okay, now to 4. Which one's B? 0.5. Which one's A? 8. Get that into your y equals and fill in your table. 8, 4, 2, 1, and 0.5. What's 0.5 divided by 1? 0.5. What's 1 divided by 2? 0.5. What's 2 divided by 4? 0.5. And what's 4 divided by 8? 0.5. Do it. Number 5. A and B, what do we know? A is 100. B is 0.5. Fill in your table. Good. 100, 50, 25, 12.5, and 6.25. What's 50 divided by 100? 0.5. What is 25 divided by 50? 0.5. What's 12.5 divided by 25? 0.5. 6.25 divided by 12.5? 0.5. Anyone starting to make any connections here? Yes, I see lots of nods. Good. Don't give it away yet because I didn't see everybody nod. That's okay. Look here. Number 6. A and B. Good. A is 200. B is 0.8. Fill in your table. 200, 160, 128, 102.4, 81.92. Excellent. What is 160 divided by 200? Are you positive? Like, how did you put that in your calculator? 160 divided by 200? Now, I know some of you have already seen the patterns, and that's good. But just to check, put 160 divided by 200 in your calculator. See what it tells you. I'm curious to know. It says 4 over 5. Gives you a fraction. Is 4 over 5 the same as 0.8? Could I write 4 over 5 here instead? Absolutely. Right? Absolutely. Okay. 128 divided by 160? 0.8. 102.4 divided by 128? And 81.92 divided by 102.4. Now, before we go on to the questions that are on the side, a student in a previous period said to me, why do we have to divide? And I said, well, because we're talking about a ratio. Ratios are usually fractions, which is a division problem. And he said, yeah, but I figured out the ratio number by saying to myself, what do I have to multiply by to get to 6? What do I have to multiply this by to get to 12? What do I have to multiply 12 by to get to 24? Does that work? So we can either think of dividing up the table or multiplying down the table, and that's the same thing. Absolutely. Okay? 2 different ways to think about it, sometimes depending on the problem and sometimes depending on your brain. How you think about stuff like that. Okay? All right, look at the questions on the side. Where does the A value show up in the table? Does it even show up in the table? Perfect. When x equals 0. When x equals 0. Every single time, A is 3, when x is 0, y is 3. A is 2, when x is 0, y is 2. When A is 200, when x is 0, y is 200. Every single time. Do you see that? What effect does B have on the table? It's the ratio. It's the change from one number to the next, the ratio. Okay? Any questions about that? How many of you saw that before I had you ask for it? Now, sometimes a lot of people see the ratio, they forget about the A. Are you okay with that? Did some of you see the B value and not the A value, or did you all see everything? Because you are so smart. All right, good. Let's make sure we have our notes filled in at the top of the next page, our definitions secure. All right. For functions in the form y equals a times b to the x power, a is the, well, we know it's when x equals 0, so we want to have that there. But it doesn't really make sense in the sentence, right? A is the x equals 0? No, so I'm going to give you some additional vocabulary words for right here, okay? A is the initial amount. Sometimes we'll call that the starting amount. And then we're going to put a comma, and then we're going to say it's when x equals 0. But it's also one more thing, depending on where we're looking at it. Guys, what do we call something on a graph when its x value is 0? What is that called? So it looks like this. X is 0 and something. 0 something. What is that called? Isn't that called the y-intercept? So what's B? B is the what do we call it over here? Oh, the ratio. Does that make sense in this sentence? B is the ratio. But again, I'm going to make sure our vocabulary is set so that we're talking, that we are communicating mathematically. Okay? It's the ratio between consecutive terms. Does that make sense? Mathematically, does that make sense to you? Good. When does the y values increase? Look back at the table before, at the page before, all the tables. When are the y values increasing? These are increasing, right? All of these. What's true about our ratio? Well, look at our ratio when the y values are decreasing. Very good. So y values are increasing when b is greater than 1. When are the y values decreasing? When b is less than 1. Very good. And greater than 0. When our b value is between 0 and 1. Okay? Any questions about that? So can you go the other way around? If I give you the table, can you find the ratio? Can you define A and B? And can you give me the equation? What do you recognize first here? A is 5. Why is A 5? Because the x is 0, right? How do we find B? It's the common ratio, right? So how do you want to think? Do you want to think of dividing or do you want to think of multiplying? Multiplying? Okay, we'll think of multiplying this time. 5 times what equals 20? 4. 20 times what equals 80? 4. 80 times what equals 320? And 320 times what equals 1280? Does it work the other way around? What's 80 divided by 20? 4. What's 20 divided by 5? 4. I'm just making sure you notice. So if A is 5 and B is 4, what's my equation? Y equals 5 times 4 to the x power. Okay. I'm not done with that problem. We need to have a conversation, but we need to go on. It's one of those things we're going to observe all the way through, and then we'll go back and talk about like we did on the previous page. Fair enough? Okay? So we all need to go, All right, look at number 8. What do you notice? A is 2. To get from 2 to 18, you multiply by 9. Good. 18 to 162. 9. 162 to 1458. Guys, is that a ratio you can see easily? Do you really know that 162 times 9 is 1458? No. This problem might be easier to do the division up the other way, right? Okay? But we know it's 9 because we are smart people. But it's always good to check. So if we know that A is 2 and B is 9, what's my equation? Y equals 2 times 9 to the x power. What about 9? Number 9. What do you notice? A is 16. Huh. This one's not as easy to see, is it? So if we do 24 divided by 16, I notice that both of these are divisible by 8, right? If I divide that by 8, if I divide that by 8, I get 3 over 2. You want to use a fraction or do you want to use a decimal? Decimal, so what's the ratio? 1.5. You guys are funny. Do you want to use a fraction or a decimal? You say decimal, and then I say, what is the ratio? You say 1.5. You're goofy. It's okay, though. It's okay. It's okay. I love you anyways. Is it really the common ratio all the way through? Is 36 divided by 24? Well, they're both divisible by 12. 1.5. 54 divided by 36? They're both divisible by 18. I know that. Do you? Look, it's still 1.5. 1.5. So that means my B value is 1.5. What's my equation? 16 times 1.5 to the x power. Do it. Number 10. What do you notice? A is already 500. 200 divided by 500. Divide both sides by, or both numerator and denominator by 100. 2/5. You want fractions or decimals? Then what's the decimal? 4/10. So 4/10 or 0.4. 80 divided by 200. Well, they're both divisible by 10. That's 8 over 20. They're both divisible by 4. That's 2 over 5. Oh, look, 0.4. 32 divided by 80. 12.8 divided by 32. So what's B? 0.4. What's my equation then? Y equals 500. 0.4 to the x power. Go back to number 7, please. Look at the equation we found on number 7. Why in the world can we not just write 20 to the x power? Why? Why can we not write 20 to the x power? Or can we? Can you multiply those two numbers together? Can you multiply A and B together? Well, the answer is no, and I really need you to know the answer of the reason why you can't. It's 3 words, and they all start with O. What does order of operations say? What comes first, multiplication or exponents? This 4 is being raised to a power. I have to do that exponent before I multiply. I cannot multiply these two together. Okay? That's going to be a big deal in the coming days when we're talking about exponents. I need you to remember that. All right? Think about these. Complete these tables. What if the equation was y equals 4 times 1 to the x? Well, 1 to the 0 power is 1 times 4 is 4. 1 to the first power is 1 times 4 is 4. 1 to the second power? 1 times 4? 4. 1 to the third power? 1 times 4? That's just like a horizontal line. right? If b was equal to 1, that just gives me a horizontal line. That's boring. I mean, unless we're talking about horizontal lines, but we're not. We're talking about exponential functions, right? What if b was a negative number? If x was 0, what's negative 2 to the 0 power? 1 times 4 is 4. What's negative 2 to the first power? Negative 2 times 4? Negative 8. What's negative 2 squared? Negative 2 times negative 2? Positive 4 times 4? 16. What's negative 2 times negative 2 times negative 2? Negative 8 times 4? Negative 32. Oh, that's weird. Alternating signs? Did you put that one in the calculator? Let me see it real fast. This is what it looks like when you put it in the calculator, this function right here. Weird. The calculator freaks out. It wants to connect everything, even though it's not supposed to be, and it looks like this. Now, if it was just that, without all the crazy lines, yes, that is exponential. But the fact that it has this part down here, that's not really exponential anymore, guys. Okay? So, answer this question for me down here. Why do you think we usually don't use these values for b? I'm going to write down exactly what it says on my answer key. They are weird. I'm not even kidding. That's what it says. They are weird. And not useful. Okay? Thank you. What are you supposed to be able to do today before you leave? How do you know you understand this lesson? Can you identify A and B? If I give you a random equation, can you identify A and B? So we're good on that, right? What's the other thing you're supposed to be able to do? Solve an equation, okay? Now, these are more, we're going to head to solving equations soon, right? But I do want you to be able to set up an equation and answer some questions about it, solve it, okay? But not in the normal sense that you understand of like solving an equation, all right? So I try to find an exponential problem that like really you have to face, and I found 2. There's way more than that, but I thought 2 was enough for today. Okay? To help with the cost of tuition, room, and board, you take out a loan for $20,000 for college. Is that realistic? Are you about to have to do that? Possibly, right? Okay? You do not have to make any payments on the loan until you leave school. I don't know if you know that, but that's real. You take out a loan for college, you don't have to start paying it back till you're done with college. However, the loan amount still accumulates interest at the rate of 12% annually. Even though you're not having to pay it back, you still have to pay the interest that's happening. Okay? Depending on if you get subsidized or unsubsidized, well, we can talk about that later. Okay? To determine how much you will owe after X years of school, complete the table and the graph. Round your answers to nearest whole dollar. That's the only part that's not realistic here. They go to the pennies. Okay? So we have a table to fill out, a graph to fill out, and an equation to write. What do you think would be the easiest to do first? You are allowed your own opinion. You know that, right? Hey, if I was doing this, what do you think I would do first? Some people think I would do the table first because we want to go left to right, right? But how did we find the table on the problems we did before? We knew the equation, didn't we? Okay, so do you think it would be easier to figure out the equation first? I need to tell you something before we go on. Sometimes in problems like this, to determine our B value, we're going to have to use that. 1 plus or minus the rate. Okay? That's going to help us find our B value. And we'll talk about why that's true in just a moment. Okay? What is our A value in this problem? What is our initial amount or our starting amount? Perfect. 20,000. And what's our B value? Well, remember I told you we're going to have to use this. The way we decide between whether we add the rate or subtract the rate is if something is gaining value or losing value. As we go through school, are we having to pay back more money or less money? More money. That's exactly right. So is it gaining value or losing value? It's gaining value. So what do you think we're going to have to do? Add or subtract? Add. Perfect. What rate are we adding? 12%. Please remember, when we're working with word problems, what do we have to do with this percent? Yeah, we have to make it a decimal. Okay? So we're going to say 1 plus, what? Perfect, 0.12. So what's our B value in this problem? 1.12. And that's going to be to the x power. Okay? So you can now go fill in the table and fill in the graph, and you'll also be able to answer these questions at the bottom. Because it says, suppose after graduating college you enter law school, how much would be owed after 8 years? What do I do with this 8? Yeah, we substitute in for x because x is how many years that we're talking about. And here it's asking for 8 years. What about after graduation you decide on medical school? How much would be owed after a total of 12 years? What do you do with the 12? Substitute it in for x. Good. Okay? Domain and range. This problem and the one at the very bottom of the page, I am not going to help you with right now. Okay? Because we've been focused on this, with our Decimals project and other stuff like that, I want to see if you can do that by yourself. We will talk about it tomorrow, though, just in case. All right? Look at the second problem. As a graduation gift, your grandparents buy you a shiny new car worth $20,000. However, due to wear and tear, the car loses 20% of its value every year. To determine the value of the car after X years, complete the table in the graph. Round your answers to the nearest whole dollar. What do you want to do first? Equation. Okay. What do you got? 20,000 is our A value. It's what we start with. What's our B value? Is the car gaining value or losing value? Losing value. So we're going to use this again, except this time we're going to say 1 minus R. What's my R in this problem? So 1 minus 0.2. What is 1 minus 0.2? 0.8 to the x value. X power, not value. Okay? Same thing down here. How much will the car be worth after 10 years? 25 years. So you're going to put both of those values in for x. And then according to this function, when will the car be worth absolutely nothing? I want you to think about that. Okay? Answer these questions. I will be checking these tomorrow when you come into class. Are there any questions besides me answering these questions for you? How can you see a graph on the calculator? You got to make sure you have the right window. Okay? Because look at the window that's given to you in this problem. We start at 1 and go to 7, but look at the y values. We're up near 20,000 and 40,000, so you have to change your window. That's a good question. Okay? Any other questions?